Hey, so this time we're making an overdrive pedal for electric guitars from mostly reused components, such as this data transfer switch carcass. We'll do resistors first. Low profile components come first and then you just move on. Caps are last. Bend it like that and plump it in. And then just bend the legs. And the diode. And the socket. Now we solder the resistors, diodes and other low-profile components. Sockets are somewhat tricky since you can't normally bend their short legs. What I do is melt some solder on the iron and use the molten blob to temporarily affix the socket while carefully holding it in position. Be cautious not to get burned. If you're just starting out, however, sizzling sounds and a plethora of curse words are probably unavoidable. Sorry. I always do one leg first to stop the component from moving. Then I reheat the joint and properly seat the component with my left hand while the solder is molten. Use sufficient heat to avoid cold joints, but do not overheat, especially capacitors, transistors and ICs. When satisfied, do the second leg and so on. Also, using a PCB stand greatly helps when you're not actually holding the board itself. If the solder stops flowing nicely and gets somewhat gummy, that means the flux has been burned off. To make it flow again, just add some more, but don't overdo it. If the blob gets too large, some solder wick can be used to mop it up. Okay, the rest of the sockets are in, so we're not gonna have any cables dangling about. We don't want any cables permanently affixed to the board because they just make a huge mess when you're handling the PCB and trying to get it in the enclosure, so we're just gonna go ahead and solder these permanently. Okay, that's done. Now we do the caps. Bend the legs a bit. Snip the legs. I have quite a collection of Chinese and also old electrolytic capacitors, and The values are not always spot on, so I like to test them before soldering them in, just to make sure everything's gonna work. Electrolytic caps are normally polarized, so be careful how you plumb them in. Watch the legs, make sure minus goes to ground and all that. Put it in, bend it, solder it. Snip the legs. Okay, so now we need to connect the components, and we do that by creating some traces on the back side of the board. So let's do that right now. You could also use some hard wire for this, stuff like this. But I'm not going to. Some mistakes were made, so I deleted those. Now we seat the socketed components, but once again watch the polarity. The two LEDs here act as clipping diodes. The third LED will actually be used as an indicator light and will feed that one 20 milliamps. And a single op amp, TL071, which goes in like that. And that's done. You just saw me prepare and solder some of the wires to the pin headers, which fit into the sockets on the board. The reason I put the sockets on the board and not vice versa is that it's much trickier to cause a short this way, as opposed to having exposed pins just sticking out of the board. The rest was pretty trivial but finicky work. I just soldered the wires to the mechanical components while trying to make it look presentable. Please note that if you overheat the wires, the insulation will melt and end up looking all mangled. So be quick and use various tools to hold the work for you while soldering. I already went ahead and tested this one, so we're ready to box it now. Moving on to the final assembly, we tighten the nuts and plug the unnecessary holes. Using some aluminum flat bar, I made these covers. The board is bolted down and some tape is used to prevent short circuits, since this is a conductive steel enclosure, although painted, and we want it to be metal to act as a Faraday cage. This way, less outside interference will be heard.
Then we wire everything. So what we have here are 3 potentiometers which simply plug in the board. Then the power socket needs to be connected to an on-off switch, just because I like having it, and from that we go to the board. Keep in mind that guitar effects normally run on 9 volts DC, where the power supply's polarity is just the opposite of what is commonly seen in household appliances. In our case, the center pin of this guy is negative and the surrounding ring is positive. If you want to protect the circuit, a single diode can be used for reverse polarity protection. Many diagrams found online already include this precaution, and if not, you might want to add one. Here, I'm using a general purpose silicon rectifier diode named 1N4001. Be careful and always check the polarity before plugging in the power supply. Then we need to take care of the signal path. From the input jack we can either go directly to the output, effectively bypassing the circuit, or to the effect and then output the modified signal. To decide between the two options, a foot switch is normally used to enable hands-free selection. A foot switch like this is normally comprised of 3 poles that simultaneously change position. 2 states are possible for each pole. This is called a triple pole double throw switch, abbreviated as TPDT. A DP-DT switch features only 2 poles, and for our application this would suffice. We'll only need 1 pole for the signal and another one for the indicator LED. Okay, so the way this works is we got 1 pole, second one and the third one. Right now these are connected. We push the foot switch. These are no longer connected, and now these pairs are connected. We bring the signal to the central lug of one of the poles. From one terminal lug of this same pole, we route the signal directly to the output. Still looking at the same pole, we go from the remaining terminal lug to the board. To identify the connections within the switch, use a multimeter set to measure continuity. Check this first before actually soldering. The other pole is used to power the indicator LED only when the signal gets sent to the board. Since we're powering the effect using 9 volts, we need a 470 ohm resistor to supply the LED with roughly 20 milliamps of current. Also, watch the polarity. Without a current limiting resistor, the LED will burn. Newer LEDs normally require less current than the old ones I have lying around.
A few moments later.
Avoid creating ground loops on the board. Also, contrary to what I'm showing here, it might be best practice to connect all grounding wires to a single connector on the enclosure. This can be done by drilling a hole into it, inserting a screw and using that as an anchor point for multiple wire lugs. In my experience, small enclosures, such as the ones used for effects pedals, have never posed an issue. However, larger ones can and have proven to be difficult. If you experience unwanted sound defects, you might want to isolate the jacks and other mechanical components from the enclosure. I had this issue once when I built a guitar amp, but we're not going to worry about it here. During the first lockdown, I made even more effects from old T-boxes that had been lying around for quite some time. Here you can see most of them, some were gifted to my buddies. The boxes were reinforced with FR4 or aluminum plates on the inside, and white montage adhesive was used to bond them in place. Alright, so I'm running a Randall RH50T and this is the clean channel.
Finally, let's use this guy to drive the OD channel. Bye!